In this question, we're given the expression 3 minus 2x squared to the 9, and our task is to find the x to the 4 term coming out of this expansion. Okay, so let's see how we could do this. One approach would be to take the expression and to actually just apply the binomial theorem fully to it and to expand it out entirely, and then just read off the x to the 4 term. But that is overkill because we only need one term, and to spend time getting the entire expansion is probably not the best thing to do in an exam situation. We're going to do this using another approach, which is we're going to use the general binomial term formula and apply it in this particular case to be able to figure out just one term coming out of the expansion. Okay, so generally this is called the rth term formula. Okay, but I've put the r in inverted commas because, as I'll sort of explain, the r doesn't necessarily correspond to the x. Okay, a bit more on that to come. Now, how have we got this? Well, it's coming out of the general expansion a plus b to the n. Okay, so we know that the a plus b to the n can be expanded to give you something like this. It looks horrible when it's in this form, but it's actually not that bad if a and b are concrete numbers and n is a concrete number. But in algebra, this looks really, really nasty. So we know that we're going to have these coefficients. These are coming from Pascal's triangle. And then we know that we're going to have a and b in each term, okay? Just a and b for each coefficient that we've got. But then the powers of a and b are going to be changing systematically, right? I've covered this in previous videos where the powers of a are going to start from n and keep going down by 1. And the powers of b are going to start from 0 and keep going up by 1. Okay, so of all of these sort of terms here, this term probably looks the meanest because it's got more unknowns than the other terms. Okay, so these terms don't have an r in them, but this one has an r in it. The reason why this has an r in it is because this is actually the general term for all of these terms. So in other words, if you choose r to be 0, you actually get this term here. Okay, so you can see if r is 0, then this is 0, and if r is 0, then the power of a is n minus 0, and if r is 0, then the power of b is just 0. But if you pick r to be 1, then you start to get this term here, right? So if r is 1, then it's going to be n choose 1, and if r is 1, then it's going to be a to the n minus 1, which is what we have in both cases, and then if r is 1, then b to the r is b to the 1, okay? And likewise, if r is n, then this term becomes this term. So in other words, if you wanted to write out the binomial expansion, you can just write this term out and then write in words, make r run from 0 to n, and then add up all the terms that you actually get, right? So this is the general rth term formula. Now, at this stage, I should say some of you may be familiar with this formula, but in a slightly different description, which is rather than having n choose r, you may use this notation for n choose r. Both of these things are entirely equivalent. So hopefully that's completely clear. And then lastly is the point I made earlier about the rth term not giving us the x to the r term, okay? And that's actually going to happen in the case of this example. So that would be explicitly shown soon, okay? So in this case, we have a specific case where a is 3 and b is minus 2x squared. Remember, we have to have a plus in the middle of our a and b, so the minus has to be tagged along inside the b, okay? So we've got our a and b, and we know our n is actually 9. We are going to stick these into our general rth term formula. So our a is 3, we see that there. Our n is 9, so that's 9, and that's another 9. And then our b is minus 2x squared, so we see that there, okay? So now we know that this is going to be the general term, quote unquote, the rth term, but we want to choose the rth term such that the xth term is x to the 4, okay? So in other words, what value of r do I choose such that this thing here gives me x to the 4 in the end, right? And I've got a power to a power, and when I expand them using laws of indices, they're going to multiply. So this is actually the rth term is giving me x to the power 2r, right? So if I choose r to be 2, if I take r to be 2, then I'm going to get x to the 4 term, okay? So now I'm going to substitute r equals 2 into this formula, okay? So if r is 2, I'm not going to have 9 choose r, I'm going to have 9 choose 2. If r is 2, I'm not going to have 3 to the power 9 minus r, I'm going to have 3 to the power 9 minus 2, which is 7. And if r is 2, I'm going to have minus 2x squared all to the power 2, which is what I've got here. But of course, that can be simplified because I can apply that power to minus 2 and I can apply it separately to x squared, which is just the law of index basically. So I've got that there. Okay. So at this stage, we're basically done because this is a number. We can just stick this in our calculator. This is a number and this is a number, right? So perhaps the most we can do is simplify that minus 2 squared to write down 4 and stick all of this in our calculator. And when we stick that in our calculator, the calculator gives us 314,928, okay? And the x to the 4 is obviously just coming along for the ride. So we've actually found our x to the 4 term. All right, so we've answered this question. I hope you found this useful. If you did find it useful, then consider subscribing.